We're at McGill University in Montreal, where they're testing top brands of bottled water. Natalie Tavenci and her team have been searching for signs of microplastics. A special dye is mixed into the water, then carefully filtered. The aim is to catch any foreign particles like plastic. From there, a microscope and some CSI-type equipment try to pinpoint the particles.
You should be able to see some particles by eye.
Oh, yeah, I see one right in there. Yeah, and there's another one there.
And finally, using liquid nitrogen and a plastic detection machine, they analyze the particles.
That little tip there is going to be right on top of our particle.
It's going to touch the particle?
Yes.
And then it can tell you what it is?
Exactly.
A waveform is created, which is then matched to known plastics. The verdict?
The graph of this particle shows us these three peaks, which are very characteristic of polyethylene terephthalate, which is the material of the plastic bottle.
PET.
PET.
We asked you to look to see if there are plastics or particles in this water. What'd you find?
So what we were able to show is that of the 50 bottles that we tested, 30 of them, we were able to identify that there was plastic.
The majority of them.
The top chart shows particles above 100 microns.
How big is that?
100 microns is about the size, the width of a human hair.
So it's pretty small.
But big enough to identify many of the particles.
We know that there are different types of plastics. So for example, we found rayon, which is a material used in clothing. And we found polyethylene, which is a material used for making plastic bottles or caps.
Surprisingly, they even found plastic in the glass bottles they tested.
This company sells water in both plastic and glass.
Exactly.
And it's still got plastic in the glass one.
Exactly.
Although in lower levels.
Yeah, it could be coming from the source, it could be coming in the bottling process itself, maybe from the air.
The question of how particles get into bottled water is just one of many mysteries surrounding this story. For instance, the bottom chart shows even tinier particles below 100 microns, and there are many more of them in every bottle. But why? And what are they?
Yeah, these super tiny ones, I mean, 2,250 in one bottle, 1,100 in another. Do we know if any of them are plastic?
So we were able to show using a very specialized technique that some of these particles are in fact plastic. We don't know how many of them, but we can indeed say now that some of these particles are plastic.